talk of the afternoon. Jared McLaren.
Oh, thank you, thank you. So I hope this isn't so bad that everyone falls asleep after lunch, but hey, I understand if you do, no big deal. I won't take offense too much. All right, so kind of kicking this off. So the title of the talk, RCEvilNet. We're going to talk about some stuff in IIS and deserialization, and eventually lead to an answer to the capture the flag today if anyone is still playing that and looking for that. So stay tuned to the end. So about me, a little bit getting into the professional side. Started out in intrusion detection, vulnerability assessments, working up through penetration testing and some application security. And now I'm the managing principal at SecureWorks Adversary Group. So I do the technical lead of our application security testing. So work a lot with web applications, APIs, mobile, code review, things like that. Help set a lot of the process and procedure. Shout out to my other SecureWorks fellow in the room here. A couple more wandering around. Spent a lot of time in defensive security. Now I get to focus on offensive all the time, which is a lot of fun. So it's kind of a fun change that I've gone into. Walking around with a alphabet soup of certifications along the way on stuff that you pick up on the defensive and the offensive side as well. Personal side, husband and a father. I'm a biker, recovering triathlete, so pray for me there. I'm still doing my best to not do those. Do a duathlon every once in a while. Love my beer, German, Belgian, whatever. Talk beer, let's crack one. So enough about me. So a wordy warning here. I'm going to have a lot of detail on these slides, and a lot of it is meant that you can take it offline, ingest it, go over a few things at home. I have a few other things that you can do hands-on that obviously no one's going to be doing during the talk. If you do, you'll be missing the stuff on the slides, but whatever. Download it later, take a look at it. And yeah, it would be easy to spend a lot of time on a number of individual slides throughout this and a number of individual topics. So we've got a lot to cover, and that's why, once again, made them a little bit wordy so you can take it offline and ingest this after the fact. So starting off with some foundational concepts here, we're going to get into what is, just in general, serialization and deserialization. And kind of in its simplest form, it's a way of basically packaging data so that someone can consume that data and unpackage it and get the data in its intended formats. So a couple really easy examples, XML. So I made just a simple XML object up there. Apologies for the small text, but if you have a person object and first name John, last name Doe, age at 35. XML is a really easy example of here are a couple words and here's a number. The person on the other end that ingests that data can easily parse it out and say, okay, these are words and this is a number. It's really easy to keep that data intact for either transfer across the wire or long-term storage and pull it out of a database later. JSON, same type of thing, just a way of basically serializing data into a transportable format that can either be transferred on the spot or stored for long-term storage and usage. So in the real world, we have a lot more than just simple XML or JSON for formatting data and ingesting it. A lot of times you see binary formats for serializers. It's the exact same concept, you just use binary wrappers instead, and it doesn't appear quite as plain text. So this is true in .NET, and it's also true in Java. Java deserialization vulnerabilities have gotten a lot of attention. There's a lot of information out there on them. .NET is kind of the same way. The way we see a lot of things serialized, it's not necessarily plain text. So one important concept is that we don't use serialization to just transfer scalar data, integer strings, things like that. We can use it to transfer objects across the wire. If you've ever looked at a thick client application, on the network, you've probably seen a lot of binary data going back and forth. And a lot of times that's serialized data that the sender and the consumer know what that format is, so they deserialize it on the consuming side, grab out the data they need, and process it. So a lot of those are objects being sent across the wire. And one interesting thing about when you start sending custom objects across the wire, the deserializer needs to know what type of object you are going to instantiate it into when you extract that data. and that's referenced as a type. A type is basically the type of object this serialized data is going to become once deserialized. So we get into some really interesting stuff when we start talking about the type that is packaged up with the serialization of that data. First one being, can you trust the type of object that serialized data says lies within? Serializers in .NET by default don't have anti-tampering checks. If I were to be a malicious person, package up some data and tell it, this is a process type, there's nothing in the serializer that says, oh, I see that's been tampered with. I know this is not a processor type. There are binders and whatnot that you can make that tell your serializer to only deserialize certain types, but by default, it's not necessarily an anti-tampering check. So another problem with deserialization in .NET, there are certain standard objects that exist in Microsoft .NET that will perform actions upon instantiation. So if I were to deserialize a given object, I would instantiate it once it was deserialized. And some of these objects in .NET can then invoke commands once they're instantiated. So it kind of makes for a really interesting scenario here. If I'm a malicious user and I know what type of deserializing library is being used on the server, and I can modify an object that's serialized, and I send it to the server, I know that I can tell it to instantiate any type of object I want to, and if I use one of the known types in .NET that will invoke commands upon deserialization, I have a method of potential command execution basically in my hands because serializers don't have anti-tampering checks built in. So there are a few of these known paths that exist in .NET today. They aren't fixed, they aren't patched, and these are referred to as gadgets. How can I serialize an object and know that when it's unpackaged on the other side, it'll actually execute code? So gadgets is a key term to keep in mind here. So, like I said, some of these exist in .NET. I have a link at the bottom of the page, but the tool that you use for generating these malicious serialized objects in .NET is WISOSerial.net. Got a reference link to it down there. And like I say, these slides will be published. They might already be up right now. I'll have a link at the end, and you can go back and take a look at some of these. Pardon me. So one gadget that exists in .NET today, an example, type confused delegate. If you were to use the program WISOSerial, it has some gadgets built in that will execute code for you if you can get a server-side library to deserialize it. And gadgets can be implemented in various formatters. When you see the word formatter in reference to .NET, it's basically a serializer. It might be an XML serializer, a JSON serializer. In the case of what we're going to talk about in a little bit, an object state formatter. That's the object in particular that we're going to get into. And it's actually really difficult to patch some of these gadget code execution paths in .NET because the .NET framework was made to be extremely versatile so that you could support anything that a developer might be able to dream up that they want to do. So it's really tough to patch some of these because if Microsoft were to come out to a patch that close the hole in a certain gadget, it may break a lot of functionality in existing applications that have been deployed over the last few years. So I'm mentioning again, WISOSerial.net is the program that I use to make malicious serialized objects. It's kind of the de facto standard in .NET deserialization attacks. So yeah, TLDR, if you can modify a serialized object that you know the server is going to deserialize, you've got a really good chance of getting code execution if there's a supported gadget and formatter in WISOSerial. And final takeaway there, HMAC validation is important. So HMAC is basically a hashing algorithm with a server-side secret key. So we'll get into this in just a minute. But if you can basically wrap some crypto validation around the serialized object that you're about to deserialize, you can tell if it's been tampered with and know that you should throw it away rather than deserialize an untrusted, tampered object. Yes, question? So the question was, the type of object you're sending doesn't necessarily have to be the type of object that the application is expecting. And that's entirely true. That's exactly the path we're heading down here. And the cool thing is, yeah, if you can either bypass their anti-tampering checks, whatever's taking place on server side, or find a way to jive with them, you can serialize an object that the server may not be expecting. And there are only a few ways that they can stop it from happening. It's kind of a scary process. And we're going to jump right into a really interesting scenario for this. So the target of my research that I wanted to go after was the Microsoft.NET ViewState. So it's still commonly used today. If you're browsing web applications that are, ASPX pages and whatnot, you may see _ all in caps ViewState. It's kind of a state object that's passed between the server and the client. And the thing that keeps the integrity so that the server knows you haven't modified that object, it tacks on an HMAC to the end of the ViewState object. This is a cryptographic, basically a cryptographic hash using a private server-side key. The client doesn't know the key, so the client can't tamper it and make it valid HMAC and have the server accept it then. If the server sees that it's been tampered with and the HMAC doesn't match the packet, it throws it away, doesn't process it. So this was really interesting to me because the ViewState itself is actually a serialized object. It uses object state formatter on the back-end server side, and if we looked back at WISO-serial.net, we'd see that it supports making malicious serialized object in object state formatter format. So it made it really interesting to me from an attack standpoint. So I wanted to take a look at this a little bit further. So another thing about ViewState, it's commonly AES encrypted as well, sometimes triple DES encrypted, and I believe it also supports DES, which I don't know who's using that. Maybe it's for export functionality or whatnot, but you can encrypt it as well. So it's relatively common to see it out there in the wild in encrypted format as well. So, and if anyone has managed an IIS server or plays around with Windows servers or anything, basically that's what it looks like from the IIS standpoint when you're protecting the ViewState with the HMAC algorithm and optionally an encryption algorithm. That's just basically the screen you would see on the IIS side of things. You can choose a validation method, which is basically SHA-1, HMAC, SHA-256, 384, and 512. And you can choose an encryption method, which is auto, or DES, triple DES, or AES. And the interesting thing that I'm really going to get into here that I focused on was if you're in a load-balanced environment on a web server, let's say you have a ViewState packet coming in and you have 5 servers behind a load balancer. If they all have different crypto keys, that ViewState that was just sent is only going to be valid on one server to pass the HMAC check. So what you do in a load balanced environment is you hard code those encryption keys, the validation key and the encryption key. You hard code those in a file called web.config, and you deploy web.config across all the web servers sitting behind the load balancer. That way, whatever server generated the outgoing ViewState that was sent to the client, when it comes back in, if it hits any of those 5 servers in the cluster, they now all have the same encryption keys, and they will all be able to prove that that was a valid HMAC signature. So that piece in particular was also a very focused area that I used for my research here. Now to get just a little bit under the hood, this is a little bit more that you can follow up after the fact, get your hands dirty on it a little bit and take a look at the code. But the .NET page object is the object that's used when an ASPX page is loaded. So it invokes the page object underneath the hood in .NET. And page objects automatically load ViewState content if it's posted to the page. So that's a really important concept to build upon here. So once ViewState is loaded, ViewState is a state bag object, and the state bag object is serialized by LOS formatter, and LOS formatter is just a wrapper for object state formatter. So that's a lot of information to flow down here, but this is kind of the thought pattern I used when going over this. So the gist of it is, if you load an ASPX page, it flows down the line, and the ViewState ingests an object state formatter object. And if we remember back, WISOSerial.net creates payloads in object state formatter format. So our attack pattern still has some valid paths here from what's out there and supported. So, like I say, that was a lot of info that I jumped over there really quick. But if you want to do hands-on after the fact, download DNSpy. That's the tool that I use for doing analysis of .NET libraries. Basically, just open up system.web.dll. That's where all these objects live that I've kind of briefly discussed here so far. They all live there. Expand the system.web.ui branch, and you'll find a few of the key objects right underneath that. And it'll basically decompile the code for you right there in line into really clean C# data. So diving in here a little bit further. So the goal is still, I want to go after IIS. I want to attack the ViewState object because I know that's a serialized object. I want to see if I can get the server to deserialize it and execute a gadget. So the goal is create an object in WISOSerial.net using the object state formatter payload. WISOSerial.net generates them. That's the underlying format of the ViewState object. The goal is to somehow sign it with a valid HMAC. Because if the server sees that it was tampered with and the HMAC doesn't match, it's just going to discard it. It's not going to process it. So we'll submit this malicious payload. If we can get past that hurdle, we'll submit this payload as a ViewState and hope that the server processes it. And if it does, the server will validate our HMAC, say, yep, everything checks out, and then it'll deserialize our malicious payload if the HMAC checks out, and reward us with riches because it'll do whatever we want it to at that point if we can jump through these steps. So these were kind of the goals of the exploitation path I had when I started down. So if we're going to, just kind of a general question here if you think about this process so far. So if we're going to sign payload with a valid HMAC, what's the one thing we're going to need to create a valid HMAC? Nick? The web config. And what's in the web config that we need? The machine keys. Excellent. So once again, kind of revisiting, HMAC is a hashing algorithm that uses a private key so that, you know, it's not like MD5. I couldn't just make an MD5 signature because there's no private key to it. Anyone could make the same MD5. So it depends on that private key that's in the web.config. Awesome. So the big prerequisite to the attack pattern that I used, because there's always a catch, the catch is you have to somehow know the validation key that's in the web.config, that's in the machine key section of the web.config. If you have that validation key, you can generate a valid HMAC for any ViewState packet that you send to the server. So how are we going to get those keys out of the web.config file? This is kind of the tricky part of this one, and it takes an existing attack pattern or some other out-of-band methods to try and get this. But how many times as a penetration tester may you have run across a server, you hit IIS, you have a local file read, but there's nothing you can do with it. You think to yourself, okay, great, maybe I can find an old SAM dump out there, and maybe there's a password that's still valid, or maybe I can read the web.config and see a username and a password to a database on the back end, but big deal, I can't get to it. I'm still out here on the internet. It means nothing to me. It's just an information disclosure. Well, the cool thing is, the attack I'm going to show you turns that information disclosure into remote code execution. So whether you're a bug bounty guy or a penetration tester, this is the type of thing that starts to truly weaponize what was once just an information disclosure. Another thing that we see really commonly, XML external entity injection. If you're able to coerce that web config out through a flaw in an XML parser library, there's another way you might be able to get your hands on those keys that are in the web.config. We just had that happen just last week on an engagement using the same type of technique. Through open source intelligence, are you penetration testing a project that's public on GitHub? If so, is it an IIS project that has hard-coded keys in the GitHub project? You may be able to tell right then and there what the validation keys are and have a valid path in to do a valid HMAC signature on a view state and go after a deserialization flaw. Paste bin, Stack Overflow, you name it. There's a chance that you may get lucky and find your target disclose their keys somewhere. Other things that you may run across if you're doing a holistic network penetration test, maybe you have access to the file system or a file share or a code repository internally, anything like that. There may be other ways that you run across what's in that web.config. Just trying to get the point across that, yes, we need to know the server-side key, but there are ways that you can get that that turns this into a viable attack. So to get into a little bit of the nitty-gritty here, this is another one. If you follow up on the slide deck, I have the exact location where you can go over some of this and get your hands dirty with it on your own and take a look at the code. But basically in the object state formatter deserialization routine, I've got a highlighted piece of code there. So when, take a drink quick. So when the HMAC is generated, it basically invokes the machine key section library and runs the get decoded data function. And the long and short of it is, this is the function that takes the entire view state, HMAC included, validates that the HMAC was the proper calculated HMAC for this view state data. That's kind of the gist of what this function does. So if we see it running here, we see this is a view from dnspy, basically a .NET decompiler that'll show you the code on screen. So it's basically taking an array, that's the entire view state. It runs this dot get MAC key modifier. So the modifier is something really interesting we're going to talk about in a minute. It's basically a salt that's added to the payload before being HMAC'd. Because Microsoft will always throw in a little of their own secret sauce, and this is one of them for generating the HMAC that's a little unique to them, and then some length fields after that are kind of moot to the point of this conversation. So next thing we're going to look at is, what is that get MAC key modifier? What is the modifier and how is it calculated? Because that ended up being a really key piece to knowing how to generate a valid HMAC that would bypass server-side controls. So once again, if you're following along on this one after the fact and want to take a look at the code, we're looking at object state formatter get MAC key modifier. That's the function that we're kind of talking about its functionality here. So there are a couple key things that take place when .NET generates the modifier, which once again, the modifier is kind of the salt that it throws on the payload before running the HMAC. So first things first, the URL is very is pivotal in generating the modifier, the salt for the HMAC calculation. You basically take the entire URI, convert it to uppercase, and then you split it into the directory and the file name. And in the file name, like default.aspx, for example, It converts that all to uppercase and replaces the dot with an underscore. So it would basically turn it into default underscore ASPX. And then the directory, let's say, just say it's temp.default, or excuse me, temp/default ASPX. It would be uppercase temp and then uppercase default underscore ASPX. It takes a hash code of the directory name and a hash code of the file name itself, adds the two together, then reverses the byte order, and that's the salt that it uses. It adds that salt to the payload and then HMACs it with a server-side validation key. So this took a little bit to walk through. It's not quite as straightforward as it sounds on this slide. There are a lot of hoops that you had to jump through to try and figure out what it did and where and tie it all back together. Yes, question? So the question was, does this salt add any security to the view state? The only thing that it really adds is collisions across pages. So if you were to have the exact same view state going to the exact same page, it would always remain the same. But because of that salt being URI dependent, if I had that exact same view state to a different page, it'd be a little different. The security itself, once we get into the details of this exploit, really doesn't add much other than, I hate to use the word obscurity, but other than a little bit of complication to being able to reverse this out a little bit quicker. It just basically was a speed bump in the road is all it came down to. So a couple key points about this page too. So when it breaks up the directory name and the file name and runs hash codes against it and adds them together, those hash codes are specific to the .NET framework. That is an absolute dependency on .NET. Its get hashcode function is different than Java's get hashcode function or other programming libraries get hashcode functions. So that's a complete dependency on .NET. All the other stuff, you could do in any language you wanted to, Python, Ruby, whatever. And then the second one, if ViewState user key is enabled, there's an additional step that's tossed into making the modifier. But for the purposes of this presentation, we're just kind of letting that one go by the wayside for now to just stick with the main core of the functionality here. So this is kind of this was the code that I tossed together to basically do it after the fact. Some of this was just taken directly from .NET. So the gist of it is you take the hash code, once again, walking top to bottom here, you take the hash code of the page name, you take a hash code of the directory, you add it together, turn it into an unsigned integer, and then reverse the byte order, and that's your salt. So this was the code that I tossed together in the tool release that I'll be doing in a bit. So once again, hands-on with dnSpy. If you want to dig into some of the details here on your own after the fact, that's the function we were looking at, get to decoded data. So now that we have the modifier, we know the ViewState payload. We're in control of that as a user. We submit that to the server. Now we know how to generate the modifier. That's the salt. Now we basically need the server-side validation key, and we have all the information we need to create a valid HMAC for any ViewState payload that we want to send. So the Cliffs Notes version here of how to do this now. So extract the payload from the ViewState. Basically, taking that step back, the ViewState packet itself is the payload plus the HMAC. We just strip off the HMAC because we're going to make our own now. Make the ViewState whatever we want it to be, turn it into a malicious object generated by WISO serial that executes the code we want it to, and we have to know the target page we're going to send it to because we need to generate the modifier for that specific page that's going to accept it, append the modifier to our malicious payload, run the HMAC routine. Now we have our HMAC signature, piece it all together, send it to the server, see what happens. Because if that HMAC passes, it's going to deserialize our data and execute the object that it was not expecting to see. So, kind of repeating myself here a little bit. So, starting with the steps. first things first, we're going to generate a malicious object state formatter in WSOSerial.net because that's what formatter, what serializer ViewState is using server side. There's a command to do that. Pretty straightforward. Basically executing calc.exe. Next, when we have that malicious payload, we need a valid HMAC, or the server's just going to deny processing it. We now know the routine of how to do this. You basically make the modifier, append it to the payload, run your HMAC algorithm, and there's your valid HMAC. Now all we need to do is have that valid signed packet and submit it to the server, pretending that it's a view state. And that's pretty simple. Submit it to the server as _ capital view state. That's the standard field name. So if all of this works out, the server will validate our HMAC. It's going to work because we found that valid machine key in a web config. So we know that we have the right key on our given target. If the HMAC checks out, it's going to deserialize our payload. And that payload, we generated it in WSOSerial. We used an existing gadget that we know exists in currently patched .NET today. It exists. And that payload is going to execute calc.exe, therefore rewarding us with our riches. We wanted a calculator. So, show me the damn code already, right? So, I'm gonna give you a link to RCEvilNet at the end of the talk here. This tool is a custom exploitation tool using known validation keys. If you extract it from the server using a file read, XXE, whatever, and you have that validation key, this tool is going to weaponize your WSOSerial packets for you, process a valid view state, server-side code execution, where you once upon a time only had local file reads. So I've verified this on a fully patched 2012 R2, 2016, fully patched 2019. Reported it to Microsoft. It's expected behavior in the application because the security of the view state is dependent on private encryption keys. So if those keys are disclosed, it's been accepted that this will happen. They actually wished me good luck at my talk today, so we're going to talk about it a little bit. So yeah, this isn't going to be patched anytime soon here. And quick bonus. I know I'm not the first one to have the footsteps walking down this path to this code execution, but you will not find any public tools or documentation in this space. I've been looking for a while. There's nothing out there publicly available that does some of this stuff. So I wanted to talk about it and show that it exists and show that you need to be a little bit concerned about the keys that you're using out there, or if you see an attacker gets a local file read, there's code execution waiting out there for them. So just wanted to raise a little bit of awareness around this one. So tool usage, once again, use this after the fact since you don't have the tool sitting in front of you, but you basically give it the URL of your target because taking a step back to generate that salt value, we need to know the URL it's going to, the directory and the file name. That's what generates that salt. So the tool needs to know that. You need to have the validation key. That's one of the requirements. That's what you're hoping to get out of the server through a file include, XXE, whatever. You need to know the validation method used. The IIS server can do, once again, SHA-1, any of the HMAC SHA algorithms. And if you don't know, you can guess. You have 5 attempts, and one of those is going to work. So you can take a guess at that if you aren't quite sure. And then it takes in a base64 encoded payload that you generated from WSOSerial.net. So generate your payload in WSOSerial, tell it what command you want to execute, and this tool will basically sign it for you, make a valid HMAC that the server's going to process. So a few usage tips. If you do get access to web config, which we hope you do so that you can use this tool, it's going to tell you the validation routine used in web config. So like this one, for example, up top, SHA-1. You'll know when you use that RCEvilNet tool to sign the packet, you'll know to tell it use SHA-1 as the hashing algorithm. So it kind of cuts to the chase for you. And also, if you're dealing with a encrypted view state, it'll always go in 16-byte blocks if it's encrypted using 128-bit AES CBC. So if you see 4 hanging bytes at the end of a clean 16-byte block, you know it's using SHA-1 as its hashing algorithm, because SHA-1 is 20 bytes. That leaves 4 bytes hanging off a clean 16-byte block. Other than that, you're going to have to guess if it's HMAC SHA-256, 384, or 512, because those all end in clean 16-byte blocks. But just a little tidbit, if you run across an encrypted one, quick shortcut to knowing which hashing algorithm it is there. So finally, once you generate your payload in WISO-serial.net, you sign it with a valid HMAC. Finally, all you have to do is post it to that target URL as __ view state equals, and you'll get this handy dandy server 500 error on the right side. The error basically says this state information is invalid for this page and might be corrupted. To your question earlier, will it deserialize the payload if it's the object it did not expect? It sure will. It'll throw you an error after the fact, but it's too late because it's already been deserialized and the code has already executed. So it's too late. View state's already done. So some of the cool stuff I found when I was going through this one, basically exploit regression testing. Every time I added a new feature, I regression tested through server 2019, 2016, and 2012. Basically everything on .NET 4.5. I didn't go into .NET 3.7 too much. It's a little bit different, but I just tried to focus on what are the current platforms out there. So found some interesting things regression testing. So going back to that slide a couple slides ago, looking at an AES encrypted view state, you may think to yourself, well, the tool I released, first of all, I didn't put encryption in this one. I left it as plain text. But the cool thing is, if the server is configured to use AES encryption, you can send it a plain text view state, and it will still accept it and process it and deserialize it. So even if the server is configured for AES, you're good to go. It's going to take it and process it. And Microsoft said that's expected behavior. We don't know when we cross over from plain text to AES, there may be some valid plain text packets that need to be processed out there. So that's expected behavior. Good to go. So on the flip side, sites configured for non-encrypted view states will accept encrypted packets. Kind of the same concept. They're supporting both of them simultaneously. So you want to get into some IDS, IPS evasion. Let's say you're going against an adversary. Excuse me. I'm on the red team side. I think blue team's adversary. So you're going against a blue team that's looking for you, and they have WISO-serial.net payloads in their IDS. Flip on encryption. You'll go right past their IDS. They aren't going to see you anymore. So even if the server's not configured to accept AES, it will accept AES. So you'll be good to go. And AES is the default encryption standard used. I honestly don't remember off the top of my head if it'll accept triple DES right off the bat, but I know it will work with AES. And the target page. We've talked a lot about view state today because that was the target of my initial research, but regression testing showed me that I could make a completely blank file in the web root, call it blank.aspx, has 0 bytes content whatsoever. It is still a target. So stepping back to the page object in .NET, when an ASPX page is loaded, the page object gets loaded, and the page object automatically loads a number of potentially expected fields or parameters. View state is one of them. So if I make blank.aspx, no content whatsoever, throw a view state at it, it still processes it, even if there's no logic in that page whatsoever. So it makes everything a target. So you get that web.config, but the entire website does not even use view state. It's still an RCE target right there, remote code execution. Couple other things. Server 2019 out of the gates shows SHA-1 in the IIS management console, but it uses HMAC SHA-256 until you hard code it otherwise. So another bug reported along the way. And Microsoft updated some crypto code paths in .NET 4.5. So when I first started this project, I thought I was going to be looking at a lot more complicated crypto code path. All the way through 2019, it still uses the old code path by default. So A lot of the stuff that they implemented in that link down there is not enabled natively by default. So it still uses some of the old techniques there, which made exploitation quite a bit easier. Cool things on the offensive exploitation side of the house. Since this is deserialization and it all basically happens in memory, this should avoid touching the disk. It's all taking place in memory. And one of the coolest parts, when I very first got this to work, I popped calc, and you could see a child process of the IIS worker process, W3 WP.exe, I think, had calc running underneath it. I thought, I'm going to restart IIS, clean it up, and run it again. I restarted IIS. The worker process went away, but calc popped on its own two legs and started living on its own outside of IIS. So what I basically found is you execute a payload through deserialization, you restart IIS, it completely detaches from IIS, runs on its own two legs. It's there until you restart the entire server or kill it manually. So if you launch a payload and you want a rat running in the background, a remote access tool, it's there. It's running until an admin restarts the box, which from a red team perspective, pretty sweet. I like it. Restarting or even shutting down IIS entirely. It's still detached from the process and running in memory. One cool thing that was added in .NET 4.5.2, we talked a little bit about making the modifier. It's splitting up the directory from the file name, running the hash codes, reversing the byte order. I started noticing ViewState generator being presented with the ViewState. As of .NET 4.5.2, ViewState generator is presented by default. It's actually the modifier in reverse byte order. So they're actually presenting you what the salt is for the page. All you have to do is take it, convert the ASCII to hex, and reverse the byte order, and that takes away your dependency on the .NET Git hashcode library. So now, knowing that, you can completely externalize your tools from .NET. You don't have to use C# anymore. You can use Python, whatever you want to, because there are no longer any dependencies on the .NET library to use that Git hashcode. Library. So kind of an interesting perspective there on tooling. So payloads for blue team visibility on the flip side of things here. The payloads generated by this tool that I'm releasing are going to be plain text. I didn't support encryption in this one. Give blue team some time here to work with this one. You're going to be seeing whysoserial.net payloads over the wire, which you're not going to be naturally seeing process.start in a view state. So something you may want to keep an eye out for. If you start seeing that going over a view state packet, bad stuff is happening out there. And host-based protection products that you might have out there, your Carbon Blacks and whatnot, they're going to see cmd.exe spawning out of the IIS worker process. So something to definitely keep an eye on from a blue team perspective. If you start seeing it doing crazy things, there's probably crazy stuff going on out there. So, demo, let's play a little bit. So I've got a server 2012, server 2016, and a server 2019 out here. So the way these are configured for demo purposes, I've got my server 2012 running HMAC SHA-512, encryption in auto mode, which means it's plain text, and the target page implements ViewState. So it kind of happens naturally. It uses ViewState. Second one, set up for SHA-1 and triple DES, just kind of showing from an encryption standpoint, it still accepts a plain text ViewState and deserializes. And then finally, a plain empty page on a fully patched 2019 and showing that could still be a target. It is not showing, is it? Let me mirror displays for you here. Thank you. There we go. Thank you for that. I knew something funky was going on here. I didn't even look over my shoulder. All right. So let's start off. Here's 2012, and this was the one set up for HMAC SHA-512, and basically uses a plain text view state. So got myself some cheat sheet here. So the first thing we're going to do to execute this guy, and we're just going to go with the assumption that we acquired these validation keys through a local file read or something similar to that. So first things first, I'm going to generate a malicious serialized payload using WISOSerial.net. So the command line options I have here, -G is the gadget. This is the code execution path upon deserialization. This is a known gadget that exists in a fully patched .NET library today. We're going to put it -F in object state formatter format. That's the underlying format of ViewState that's used on IIS in .NET. We're going to output this payload in base 64, and we're going to run the command ping localhost 10 times. Just something that pops up, we can see visually, and then it goes away, just for a proof of concept purpose. So there is our malicious serialized object, but it does not have a valid HMAC whatsoever. So next step is we're going to sign this object using RCEvilNet. So I'll go through the command line options here when I pop it out. So command line options. We are first going to give it the target URL. I just made an example page that has a subdirectory and then a page in it. And then the hashing algorithm for this target server is HMAC SHA-512. And the validation key. Please don't copy and paste this one. This one is for testing purposes, and use it if you want to, but use it at your own risk. Let me put it that way. So this would be a validation key that you would have collected out of web.config during a penetration test. And then finally, give it the payload from WISOSerial.net, the malicious payload that you just generated, and we want to sign that using HMAC SHA-512 with this validation key based off a salt on this URL. So when we do that, tool nicely URL encodes everything for you and gives you a nice payload that we can go straight to burp. So this was a natural ViewState packet between the server. Everything looks good. We see over here our IIS worker process spawned. Now if we switch to the exploit packet, we basically paste in the packet that we just signed into the ViewState parameter, and boom, ping spawns over here. So in a fully patched 2012 server, we just achieved remote code execution by running a gadget in the latest .NET library on the latest revision of Server 2012, all because it disclosed its validation key to us through a penetration test. Now we have full code execution. We've gone from trying to find some kind of information on the server, basically information disclosure, to remote code execution. So the next example, this server was configured for SHA-1 and triple DES. So if we were to look at this server, Burp's nice little ViewState tab, we can see it doesn't recognize the format. It must be encrypted. This is a triple DES encrypted packet here. And remember, during regression testing, I found if the server's configured for encryption, we can send it a ViewState, and if everything checks out, it's just going to process it anyway. So let's see what happens. Used the same packet. I went back through, I prepackaged these, but I basically went through the same routine, made ping localhost 10 times, and then signed it using SHA-1 as the hashing algorithm for this one. Let it loose, worker process spawns, ping runs on the back end. And this is a plain text view state. You can see right there, everything is clear as day. System version equals blah, blah, blah. This is in plain text. The server was configured for encryption. Still works. Good to go. But what about Server 2019? Oh, Server 2019. Sure, let's do that next. So this one I have configured. It's using HMAC SHA-256, and I literally have one page out there called blank ASPX. There is no content in this page whatsoever. I guess I can go to the page instead of just trust me. See how live demos go. SOL. So blank ASPX. Literally nothing there. It is a completely blank page. It's empty. It's 0 bytes in size. We run through the same routine. Make a payload in WIEWSTATE.net. Tell it the URL is blank ASPX. Feed it the proper validation key that we acquired through a penetration test. Send it right after the server, and boom, still executes code. The page itself has no logic in it. It has 0 byte content, but in the background loads the page object, which automatically loads ViewState, which automatically processes and accepts our serialized packet that passes the HMAC. And this is a fully patched 2019 server. So fun little tool to add to your utility belt, going from information disclosure to full remote code execution. All right, I've got just a couple slides here to wrap up. All are good. So wrapping up, basically, don't ever use keys that you copied from someone else. Don't copy them off the web. What is it that Eric Johnson always says? Don't copy code from strangers? Something along those lines? Yeah. Don't copy them out there. If your server's ever been compromised, recreate your hard-coded keys that you had in web config behind your load balancer. If your web config was modified unexpectedly, regenerate your keys. Someone may have done that maliciously. If your website's ever had a read flaw or an XXE flaw, regenerate your keys. If you're in doubt, regenerate your keys. Don't leave them out there. Recycle them. If anyone ever got their hands on them, it's a ticking time bomb, a remote code execution on a fully patched system out there. So we've got some awesome applied research on this subject that I'm hoping to be talking about somewhere in August. We'll see. Some really cool stuff that we've started taking off with this. This is just the tip of the spear on some of the things that you can be doing with this. You want to learn more about this? Here are some resources that you can take offline. Once again, slide deck's going to be published so you can take a look at it. And finally, give me the damn tool. Here are a couple links. So we've got a link to the blog post here, illuminapi.com, and RCEvilNet, the download link. I published the code before we came in here today. So the code should be out there. Feel free to take a picture, take a click, go grab the code, go play some CTF, and stay tuned for future research projects. Really looking forward to talking about some of those someday. So any final questions before? Yes, the gentleman in the blue shirt. So what platform was it written in? I wrote it in on Windows on a fully deployed .NET deployment. I wouldn't be able to tell you if it runs on core. My guess, I believe I tested it along the way. My guess is that it's not because of the hash code dependency. The hash code function in particular, I believe, was a Windows dependency in that deployment of .NET. Yes, sir. So the way that, I'm going to kind of answer your question. The way the WIEWSTATE.net payloads are set up, it will always invoke process.start in .NET, which invokes cmd.exe/c, then your command. So that's how this tool is designed to launch payloads. It's possible that behavior may change in the way someone else codes it. Yep. All right. All right. Thank you, everybody.